Dryad's system for early detection of wildfires is called Silvanet Suite. 4 components: the sensors, the mesh gateways, the border gateway, and the cloud platform provide a fast operating network that detects a fire in minutes and sends the alarm to your cell phone or other devices. Watch this video to learn how to install Dryad's Silvanet. For detailed installation support, please refer to the user manual or contact us. Unboxing the Dryad Silvanet Suite.
Hi, I'm Eric from Dryad. The sensors, the mesh gateway, and the border gateway are delivered in separate boxes. I will give you a brief overview of the contents of each box and how each device works. The sensors are packed in slim boxes of 10 sensors each.
The sensor's primary function is to analyze the gas composition of the air. If the gas composition of the air changes due to a forest fire, the sensor will detect this within minutes and send an alarm using the mesh network. The AI-based sensor is a digital nose. It can reliably differentiate between natural smells and a forest fire. The sensor also monitors the microclimate of the forest by measuring temperature, humidity, and air pressure. The gas sensor is located behind a membrane, protecting it from water and dust.
Each box contains everything you need for attaching the sensors to the tree.
The tree nail is made of oak, which ensures that the tree is not poisoned by copper nails or other metal nails that allow bacteria to penetrate the trunk. And these are the spacers. The spacer allows the sensor to hang vertically, so that resin and sap are kept away from the gas sensor and the solar cell.
The tree nail is meant for permanent installations, while the crop wire is suitable for temporary installations. Later, when setting up the network in the forest, I will show you how to use the spacers together with the nails.
The sensor uses LoRa to connect to the internet. The gas measurement, as well as the data transmission via LoRa, requires little energy and can be operated completely on solar power. The border gateway connects the network of sensors to the cloud platform using 4G LTE-M or NB-IoT, or using a wired Ethernet connection. It communicates with the Silvanet cloud through the internet to relay messages from sensors via the mesh network.
When you open the box, you see on the top layer the border gateway and all the components you need to deploy the gateway. Underneath, you will find the solar panel with all the corresponding connections. The border gateway can be securely attached to a tree or a pole using the tree nails or the U-clamp. For the solar panel installation, you use the provided crop wire. In the middle, you have the border gateway itself, the PoE adapter, and the solar panel connection. The border gateway comes with 2 antennas attached. At the top, we have the LoRaWAN antenna. At the bottom, we have the LTE-M and NB-IoT antenna. Also, there is the swarm antenna, which needs to be attached to the side of the border gateway. In this small box, you will find the PoE adapter. This adapter connects to the border gateway to supply it with a power source. And here, you will find the Ethernet cable, which you can use to connect the border gateway directly to a modem or a router, so that you can provide internet directly to the border gateway.
You can operate the gateway on PoE or only with solar power. We recommend operating the border gateway with both PoE and solar as a backup. In the event of a power outage, the solar panel will continue to power the gateway, and the built-in supercapacitors will support operation even at night. To connect the border gateway to the internet, you have the option via an Ethernet cable to a modem or operating via mobile 4G network connection.
Later, when we're in the forest, I will explain how to connect the sealed PoE connection to the Ethernet cable.
Mesh gateway. The mesh gateway extends the range of the border gateway, building a multi-hop LoRaWAN network, receiving and forwarding messages from and to the sensors. The mesh gateway is optimized for low power consumption, and the built-in solar panel is sufficient to cover the daily energy budget.
When you open the box, you will find the mesh gateway itself and similar accessories. You can install the mesh gateway temporarily using the provided crop wire to perform the range test. Then you can install the gateway permanently using the 3 nails once you have finalized the location. If you want to deploy the mesh gateway on a pole, then you use the U-clamp. Over here, we have the LoRaWAN antenna, and that screws on the top of the mesh gateway. Once it's screwed in, that's it. It's ready to use. But we recommend screwing the antennas into the devices only if you have deployed the gateways on the tree or on the pole.
So we recommend screwing the antennas into the devices after they are attached. All the mesh gateways and the sensors will automatically register with the Silvanet cloud during the deployment process. The mesh gateway, just like all the components of the Dryad suite, are tree ready. All you have to do is unpack them, put them in your backpack, grab some tools and head out into the forest. Planning. In this segment of the video, we will be discussing the process of planning the deployment of Silvanet Suite for the forest area you want to protect. Firstly, we will provide you with a brief overview of the steps that need to be taken. There are 3 steps involved in using the Silvanet system for forest monitoring. The first step is to do some scouting on the site. The second step is to plan the deployment of sensors and gateways using the Site Management app on your computer. The third step involves building deployment packages. By breaking down the total area into smaller segments, you can ensure that the work in the forest is organized and efficient. To deploy Silvanet devices, the forest workers use the Silvanet app, which is installed on their smartphone, to guide them to the planned deployment locations. You can download the app from the Google Play or Apple Store. The app is designed to help the deployment process and ensure that each device is properly installed and functioning. Scouting. To use the Silvanet suite optimally, it is helpful to get an overview of the topography, the tree population and human activities in the deployment area. As most fires are caused by human activity, sensors should be placed in higher density in areas of human activity. Before you start planning, it may be useful to visit the site and view the topography online. Answer a few questions, such as where are people in the area, where are the hiking trails, camping or picnic sites and outlook points, and where are the critical points such as power lines, railways, field paths, roads? And about the forest itself, the questions are how dense is the forest? Is the terrain hilly with much undergrowth or full of rocks? Understanding the terrain and topology is important when determining the position of gateways to provide network coverage in the target area. Planning deployments with the Site Management app.
This is the second step of the planning process, where to place the devices based on density and range. To achieve effective protection against forest fires, it is necessary to place the Silvanet devices carefully. In the following, I'll show you how to plan the deployment in the Site Management app. You can log in to the Silvanet Site Management app using the access codes that you have received from Dryad.
To learn about the features of the app and how to use it, you can refer to the user guide, which is available under the Products Documentation menu item on our website. Or by clicking on the book icon located at the top right of the Site Management app. This web app provides an easy way to choose the locations for your Silvanet devices. The Site Management app can also be used to view environmental data from all sensors. It displays the status of each device, whether it is active, inactive, or has detected a fire.
Let me guide you through the process of using the Site Management app to plan your deployment effectively. To head over to the Planning section, click on Sites, search your respective site, and click on the Planning button on the top right corner to pull up the Packet Creation section.
In order to properly position the sensors and gateways, it is important to consider the distances between the devices. Before actually getting started, here is some information about the range of the Silvanet system. Silvanet sensors can detect fires within a radius of up to 80 to 100 meters. They can communicate with mesh and border gateways that are 1 to 2 kilometers away from the sensor. Depending on the density of the forest, the mesh gateways communicate with other mesh gateways or a border gateway over a distance of 2 to 3 kilometers. These are approximate figures. They can vary significantly, depending on the type of terrain and forest.
For more information, see the user guide.
The packet planning groups Silvanet devices together in small packages to make planning changes easier and simplify work in the forest. We recommend treating the border gateway as one package, the mesh gateways as another, and the sensors as packages of up to 25.
Let's get started. The best way to begin your planning is by placing the border gateway first. Click on Add Packet. Name the packet Border Gateway. Add device to packet. Choose the border gateway. Add your respective amount, in this case 1, and then add. Now pick your location. Click on the border gateway and place on map. You can drag and drop the border gateway to your desired location. And don't forget to click Save.
Choose a place where the gateway can be operated, ideally via a reliable power supply, and if possible, it should be connected to the internet using a fixed internet connection. If mains power and/or fixed internet cannot be provided, the border gateway can also be operated on solar and using a mobile 4G network connection. To ensure an uninterrupted operation, it is important to select a location with direct sunlight, such as a tree on a hillside or a pole away from other trees. Please keep the solar panel connected, even if you use mains power. This is important because the pre-connected solar panel acts as a backup to charge the device's internal energy storage. If a loss of power occurs, the solar panel will keep the system running. In the documentation, all possible scenarios are described of how the border gateway can be operated. Planning the mesh gateways.
Before I come to the mesh gateway, let's jump back to the border gateway so we can make it clear how both of them work together. The border gateway sends and receives data to and from the mesh gateway up to 3 kilometers.
So you have to take into consideration the distances between your gateways. To add a mesh gateway to your site, click on Add Packet. Give the packet a name. For example, Mesh Gateways. Click on Add Device to Packet. Choose Device Type, Mesh Gateway. Then choose the amount, in this case 2. Click on Add, and then you see the 2 devices in the list. Search for the location of the mesh gateway on the map in your area. Then choose Mesh Gateway 1 and click on Place on Map. Drag and drop the icon on the map in a distance of up to 3 kilometers and in the line of sight to the border gateway. In the same way, you can place the second mesh gateway on the map. The distances between the devices will show up on your map. To maintain a stable connection, it is important to install the border gateway high up in the trees and within the line of sight of 1 or ideally 2 mesh gateways. It should be facing one of the mesh gateways with line of sight and minimal obstacles such as trees or branches that could disturb the radio transmission. The mesh gateways don't require a mobile network connection as they utilize the same LoRaWAN network as the sensors. They require less energy, but the gateway needs direct sunlight for its built-in solar panel. It is recommended to mount the gateway facing the sun at noon on a freestanding tree approximately 3 to 4 meters high, ensuring no branches shade the solar panel. The height protects the mesh gateway from human or animal interference and gives a better line of sight to other gateways within range. The sensors.
To add the sensors after placing the gateways on the map, you have to once again click on Add Packet, give the packet a name, choose the respective devices, and set an amount. In this case, it's 10. Head over to your first location, and you can individually choose the sensors that you want to place here. Click on Place on the map, and then you can drag and drop the icons to your desired location.
The sensors are capable of detecting gas within a range of 80 to 100 meters. While placing the devices, you can observe their distances to determine if they are close enough. If the location has a high level of human activity, we recommend placing the sensors at closer distance of 30 to 40 meters.
Now head over to the other side of your deployment, and you can click on Device Name to select all of the remaining devices and then place them on the map together. Once again, you can drag and drop to your desired location. Once you have set all the devices, as always, don't forget to save. Once you have completed the planning by creating the packets in the Site Management app, you will find all the packets under the respective site name in the Silvanet app on your phone. Then finally, you are ready to deploy in the forest.
Deploying Silvanet devices. The devices are tree ready. You can unpack them from the cardboard boxes and store them in your backpack or other carrying bags. Take the Silvanet accessories, wire, tree nails, spacers, etc., and some work tools. A list of required tools can be found in the documentation. A stable ladder, cordless drill, hammer, pliers, small axe, etc. And don't forget a nice lunchbox.
Mesh gateway in the bag.
To prevent damage to the gateway antennas, it is recommended to unscrew them or not screw them before packing the backpack.
Thank you.
For safety reasons, it is always advisable to work in teams of 2. Arriving in the forest. Finding the planned spot. Open the Deployment app. It shows the list of your packages. Choose the device you want to deploy, for example, a sensor, and press the Map button to display the sensor's planted location. and your own location as a blue dot, allowing for easy navigation.
The app works offline. No need to worry about having a bad LTE connection. All right, the sensor's here, so we're gonna go that way.
Arriving at the site. At the patched site, you must decide whether this location meets the requirements for the device. Is the tree tall and sturdy enough? Is it planned for cutting, or is it in any way unlikely to survive for the duration of the lifetime of a Silvanet device? If you have any doubts, find another tree within the radius, 20 meters, of the planned location. The Silvanet system will remember the new location of the device and display it in the management app as soon as you scan the QR code using the app. In case you don't have an LTE connection in the forest, the data transfer will happen as soon as a connection is established.
And the tree looks tall and sturdy enough, so it should be good.
Don't forget to scan the QR code.
Good point.
Before climbing the tree, scan the QR code on the back of any device. By scanning, you register the device ID with the Silvanet cloud. After registering the device ID, it is linked to the GPS location.
Ready.
The deployment app automatically fills in the sensor's latitude and longitude using the smartphone's GPS position. In the deployment app, you can make notes about the specific device and place, like the place is a bit shady or nearby is a barbecue area. This helps to track down errors more quickly if the sensor or gateway does not function optimally. Installing the sensor. Once you find the optimal location, attach the device to the tree at a height of 3 to 4 meters and facing south. While the sensors do operate even in the shade, they work better with direct sunlight. If any branches are blocking the sunlight, it may be necessary to trim or remove them. If you are deploying the device temporarily, please use the crop wire. To attach any Silvanet device permanently, we recommend using tree nails. The nails made from oak wood are harmless to the tree and expand with the tree's moisture, ensuring a secure fit for an extended period of time. If you want to nail the sensor to a tree with heavy and crusty bark, carefully remove a small portion of the bark. Then drill a hole approximately 6 to 7 centimeters into the tree using the 10mm drill bit.
Could you pass me the drill, please? Thank you. Pass me the hammer, please.
Insert a tree nail through the sensor's loop. Slip a spacer onto the tree nail, then carefully hammer the tree nail into the hole. If you are temporarily installing Silvanet devices, use the crop wire for mounting. To do this, you pass the wire through the loop in the sensor and the spacer. Then you lead it around the trunk and twist the wire tightly, Tangle the loose ends so neither animals nor a storm can loosen the connection. Make sure that the sensor is securely in position, hanging loosely and vertically. After attaching the device, you may take a photo for documentation purposes. Installing the mesh gateway. As always, take your time to select the right tree and scan the QR code before attaching the mesh gateway.
That tree looks good.
Alright, let's do it then.
To install the gateway permanently, you need 4 tree nails. If you are installing the gateway temporarily, use the crop wire provided. To install the mesh gateway in 3-4 meters height, you may need an assistant to support the mesh gateway while drilling and hammering. First, drill the holes with space 70 millimeters, 7 centimeters apart.
Now we mark the position.
To make the spacing simple, you may use the provided U-clamps to mark the distance between the holes.
Perfect. Thank you.
Drill the holes approximately 6 to 7 centimeters deep.
Thank you. Can you pass me the hammer, please?
Then hammer the tree nails through the top and bottom loops of the mesh gateway into the drilled holes. Last, screw the LoRa 1 antenna to the mesh gateway. Please make sure the antenna does not tilt when screwing it in. If it's not straight and tight in the thread, there's a risk that the radio connection will not be established correctly. Installing the border gateway on a pole. The best place to install a border gateway is one that has access to PoE, Power over Ethernet, or at least mains power and a wired internet connection, for example at a campsite, a forester's lodge, a visitor centre, etc. At a minimum, the border gateway needs to be installed in a location with decent mobile network, LTE-M or NB-IoT connectivity. It is recommended to mount the border gateway and the solar panel on a pole. When installing the solar panel, please make sure the panel is installed above or below the gateway, not on the back of the gateway where it would block radio waves. If you're planning to use mesh gateways, the border gateway needs to be deployed within range and ideally with direct line of sight to one or more mesh gateways. To install the border gateway on a pole, you need the U-clamps and the 17mm wrench. So you are well prepared. Store the removed antennas carefully. Before you start attaching, please scan the QR code and disconnect the solar panel in order to attach the devices securely. To attach the gateway to the pole, you can use the U-clamps. To maximize the radio contact, put the gateway on top of the pole so the antenna is above the top of the pole. The maximum diameter of a pole may be 60.3 millimeters. Insert the U-clamp through the top and bottom holes of the border gateway and around the pole, and tighten the nuts first. Then use a wrench of 17mm to tighten them firmly. Be careful not to damage the gateway. finally, attach the antennas to the border gateway. Make sure to attach the LoRa antenna at the top and the LTE antenna at the bottom of the device. And please make sure that the antennas are screwed in straight. Connecting the Ethernet PoE cable. If you're planning to connect the border gateway using Ethernet and PoE, we will now show how to connect the sealed connector on the device to the Ethernet cable. Plug in the Ethernet cable into the PoE adapter. This is the sealed connector to attach an Ethernet cable to the device. Open the connector at the border gateway by unscrewing the cap. Disassemble the connector, and now you have three parts in front of you.
Thank you.
The end cap, the sealing ring and the housing. Now lead the Ethernet cable through the end cap, enclose it with the sealing ring and lead it through the housing. Plug the cable into the Ethernet socket in the connector. Carefully seat the sealing ring in the housing without damaging the barbs. This ensures that no moisture or water can leak in later. Screw the end cap on the housing and screw the housing to the connector. Now the connector is reassembled. It is recommended to perform this procedure once before going into the forest and installing the device. When installing, make sure that the parts are firmly screwed together. This also prevents water from entering.
Good.
The solar panel. The solar panel should always be attached, even with a PoE or mains power connection, to ensure an uninterrupted power supply. The solar panel can then be installed underneath with the crop wire. Divide the wire into two pieces that are significantly longer than the circumference of the tree or the pole. Thread the wire already at the ground into one of the holes at the top and one at the bottom of the panel's backside. One way to securely attach the panel is to hug the tree or the pole. The tree or pole is between you and the panel. From behind you can hold the panel with one hand while the other hand can knot and tangle the wires. Once you have the upper wires attached, the panel hangs and you can take your time to tighten everything properly and twist the overhanging wires so that neither weather nor animals can get hold of them. Now reconnect the cable between the panel and the gateway that you disconnected before and store the cable carefully. Fortunately, the sensors and the mesh gateways do not need any further maintenance. Any software updates to the sensors are then done remotely.
Right, let's go.
After a Silvanet sensor has been deployed, the gas sensor requires 14 days to calibrate to determine a value for normal air in the environment around the sensor. The gas sensor in the Silvanet sensor is very sensitive to outdoor changes. Consequently, moving, touching or interacting with the sensors beyond what is necessary influences the sensor's readings and also the sensor calibration settings. Do not disturb the sensor. During the calibration period, the sensor does not detect smoldering fires. After 14 days, the gas sensor environmental readings stabilize to an optimal level of sensitivity and it is ready to go. Testing. In this part of the video, we will show the best practices for testing the Silvanet system. A test may be useful to demonstrate the effectiveness and efficiency of the Dryad Silvanet system to an audience, media, investors, politicians, etc. For this purpose, it is advisable to equip a designated area, preferably near the border gateway, with sensors, and in a higher density than is usual to provide optimal detection speed. The test area should be like the area where the Silvanet system is installed, a forest. A parking lot, sports field or schoolyard is not useful, as there could be too much interference for the sensor and false alarms could be provoked. Nevertheless, make sure that the area is easily accessible for the audience and the fire brigade, which should supervise the test. If the border gateway is out of range, install a mesh gateway at the test site and proceed in the same way as described in the chapter Deploying Silvanet Devices. Use 2 boxes of Silvanet sensors, 10 in each box. When installing the sensors and the gateway, make sure that the QR codes have been scanned and the location allows the devices to have sufficient sunlight. Deploy the sensors in a dense grid of approximately 10 to 15 meters distance from each other. By reducing the distance between the sensors, the detection time and amount of burning material needed for testing and validation are significantly reduced, ideal for a demo. You will find some examples of the arrangement of the sensors and the fire pit in the documentation under the keyword Testing Preparations. And just like in the deployment area, sensors must be calibrated in the planned location for 14 days. Remember, do not interact with or move the sensor immediately prior to the test. Ideally, leave the sensors alone for at least 24 hours before performing the fire test. After the sensors and border gateway have been deployed and calibrated for 14 days, ensure they are communicating with the Silvanet network. You can verify this using the Site Management app. Open the site dashboard and select Sensors. Active sensors appear as green icons. Inactive sensors appear as grey icons. To prepare the fire, collect and dry burnable materials from the environment. Wood, branches, twigs, even greenery, needles and leaves. To make the test as realistic as possible, ensure you have sufficient material to burn and maintain a test fire. We recommend burning about 6 to 8 kilos or more during the test. To reflect conditions of real wildfires, the test fire should not diminish as the test runs, which should be at least 30 minutes. Use a metal fire pit with a diameter of approximately 1 meter and place it in the middle of the deployed sensors. Start the test fire by igniting small dry branches and slowly grow the fire. Please do not use any chemical fire accelerants. Feed the fire with small branches and add smaller branches with needles and leaves on top of the fire. Constantly feed the fire with fresh material to ensure the fire continuously burns for 30 minutes and produces a lot of smoke. As the direction of the wind cannot be controlled, provide sufficient time for smoke from the test fire to hit the sensors. The sensors need to be exposed to smoke for 1 to 5 minutes to trigger a fire alarm. You should expect a fire alert in the Site Management app and receive a fire alert email. A flashing fire alarm icon on the map displays the exact location of the sensor detecting fire. In the case of an emergency, the fire brigade can very accurately identify the source of the fire and extinguish it, which they should also do after a successful test of the Silvanet system. Make sure you completely extinguish the fire after the test and do not leave any ember behind. But what remains is the feeling of having done something to protect the forest, the animals and the people with the Dryad Silvanet system.